Hello students, today I am here to discuss one of the beautiful topic of organic chemistry, that is reactive intermediates. You know, the organic reaction proceeds through the intermediate, and which intermediate thereafterwards on combining with some reagents leads to form the products. So there are 6 such reactive intermediates that we have to discuss today. That is, we shall discuss it one by one: carbocation, carbon anion, free radical, carbene, nitrene and arynes. So these reactive intermediates, they are formed not at the initial of the reaction or not at the end of the reaction. They are formed during the middle of the reaction, where it there combines with the further reagents that come across in the reaction, and later it is get converted into product. And the lifespan of the reactive intermediates very short. With a short period of that means within a short period of time, they get initiated and they get terminated. So reactive intermediates, they are the organic species formed in the middle of the reaction rather than at the initial or at the end. But as a name indicates, they are highly reactive. Because of that highly reactive nature, the lifespan is very less. So we shall discuss the one of the reactive intermediate, that is the carbocation. Now, what are carbocations? The organic ions which contain a positively charged carbon atom are called carbocation. They are formed by the heterolytic cleavage of covalent bond. You know how the covalent bond get cleavaged. So there are two types of cleavaging of covalent bond, that is the heterolytic cleavage and the homolytic cleavage. So carbocation formation takes place only because of the heterolytic cleavage of the covalent bond. So this is how the covalent bond is broken, that is heterolytic breakage of covalent bond leading to the formation of the carbocation. And carbocations are electron deficient species. They are electron deficient species, and they are get stabilized whenever they are present with the electron releasing groups like alkyl groups. So when we discuss the stability of the carbocation, can be clearly seen that always the tertiary carbocation is most stable when compared to the primary and secondary, because tertiary carbocation, in that particular carbocation, the hydrogen is replaced by 3 alkyl groups. You know, the alkyl groups are they are good electron releasing group. As the carbocation is deficient one, by releasing electrons to that particular carbon, it enhances the electron density over carbon and it gets stabilized. You know, always the deficient stable or comfort with the sufficient one, as you know. So because of that, the tertiary carbocation is stable when compared to secondary and primary. When compared to primary carbocation, the secondary carbocation is most stable because it consisting of two, as the name indicates, it consisting of 2 alkyl groups, which increases the electron density again on the carbon atom, and it is stable. And the primary carbocation is less stable when compared to secondary and tertiary carbocation. And let us, we shall discuss the one more reactive intermediate, that is carbon anion. It is also a species with the unshared pair of electron and the negative charge on the central carbon atom, and these are electron sufficient one. Whereas the carbocation is electron deficient, but carbon anions are electron sufficient. Here it is also formed by the heterolytic cleavage of a covalent bond. It is also formed by the heterolytic cleavage of the covalent bond, but covalent bond is broken, but here pair of electron is shifted on the carbon atom rather than the atom to which it is attached. Now, here in a case of the carbon anion, as you know, it is electron sufficient. The electron releasing group will obviously will unstabilize the carbon anion. So here the stability is exactly ulta of carbon cation, because carbocation is being deficient, it needs an electron releasing group, whereas the carbon anion being electron sufficient, it needs an electron withdrawing group. So because of that, always tertiary carbon anion is less stable when compared to primary carbon anion, carboanion. So why the reason is because the carboanion itself is highly sufficient one. Whenever you are very sufficient, addition of again the sufficient one doesn't make much difference, but always a deficient, if a deficient one is present with a sufficient one, there is some comfortable you feel. The same thing here also, whenever carbon itself is in the case of carbon anion is itself is sufficient, so that's in order to be stabilized it requires a withdrawing one. So always because of that, they always the tertiary carboanion is less stable when compared to secondary and primary. In this case, primary carbon anion is most stable. So the order follows like this, and this carboanion is formed during the aldol condensation. You know, it's one of the main organic mechanism that you will come across during your BSc course. So let us study the one more reactive intermediate, that is carbene, which is having a lifespan less than 1 second. So you can just imagine how reactive it is. A lifespan is less than 1 second. So what are carbenes? So these are the neutral organic species containing a divalent carbon atom having sextate of electron but no charge on them. So you have to always remember, you should be in a position to differentiate the carbene and carbon anion. Carbene is having containing a divalent carbon having a sextate of electron but no charge, but carbon anion is always represented through a charge. So you know, in a picture you can see there are two types of carbene, that is methyl carbene and dichlorocarbene, and carbene is always represented by 2 electrons, sometimes with the bond, but most of the time they are presented through a pair of electron. Now, so there are 2 types of carbenes based on the arrangement of the electrons. So that is triplet carbon and the singlet carbon. So the 2 electrons present on the carbene, if they are paired up, that is normal case in a orbital, how the electron is pairing, if that kind, then that is called as the singlet carbene. And if in a case that 2 electrons in a orbital they are not paired, they are parallel, that means it is a biradical, or it is also called as the triplet carbene. So there are 2 types of carbenes, triplet and the singlet. That is, when 2 electrons on the carbon atom are paired, then it is singlet, and in the triplet state it is an unpaired. That is, they are parallel to each other, they are not an opposite spin, they spin are parallel, that means they are in a same direction. So during the collision is a phenomenon that occurs in a case of the triplet carbene, it leads to formation of 2 types of compounds or 2 types of complexes, cis and trans. It's because of this triplet. Whenever the singlet carbene undergoes reaction, there is no question of cis and trans, but when in the case of the triplet carbene, there is a question of cis and trans, because whenever there is a phenomenon called as collision takes place because of that. So as it is, carbene itself is sufficient, there is no question of electron donation or withdrawing group. So it is stable as it is. This is how the carbenes undergo a reaction, that is an generation of the carbene, and thereafterwards on addition to alkene, its formation of a product. let us study the free radicals. So, I always compare these free radicals to bachelors and spinsters, because before bonding or before marriage, these bachelors and spinsters, like the unmarried woman and unmarried man, they will be highly active, they will be always keep on disturbing others. Free radicals is one such organic species. They are highly reactive, highly disturbing one. So, in order to define this free radical, an odd electron neutral species which are formed by the homolytic fission of a covalent bond. As I discussed earlier, there are two types of bond breaking, that is heterolytic and homolytic. So, this is formed mainly because of the homolytic cleavage. So, during anti-Markovitch addition of hydrogen bromide to propene, this free radical intermediate is formed. The free radical intermediate is formed. So, homolytic cleavage takes place where the equal sharing of electron or a bonded pair of electron being distributed equally to both the species attached or involved in the bonding. So, free radicals in our heart also, or this in our heart and in our whole body, free radical plays a very important role. You know, one of the interesting fact of free radical is this cancer is or tumor is caused mainly because of the free radical. So, you know, a measured intake of chocolates, it inhibits as it contains a caffeine, that it inhibits the formation of the free radical, prevention of free radical. Thereafterwards, the tumor is avoided. So, American research says that a better or a measured quantity, particular quantity of chocolates can prevents the tumors. So, this is about the free radical. So, this is how the free radical is formed, and if you compare the stability of the free radical, tertiary free radical is most stable when compared to the primary and secondary, as in a case of carbocation, as free radical is electron deficient. Obviously the tertiary carbocation, the free radical is most stable. And next we shall discuss is the nitrene. Nitrene is similar to the carbene. They are also electron deficient, in which nitrogen has 6 electron. There are also two types, that is singlet and triplet, and you know, as it is to related the similar compound, or you can say it is also an analogues of carbene. Nitrene is an analogues of carbene, which is also called as an azocarbene. Everything is similar to carbene. So, again the tertiary nitrene is more stable when compared to primary and secondary. And one of the important reactive intermediate that we have to study is arynes. So, it is formed when an aryl halide is treated with a strong bases like sodamide or potassium amide. So, the reaction how this is formed, this slide shows the reaction how exactly the benzene is formed, and benzene is a very reactive one, where the benzene the benzene formation is also involves the change in the hybridization. You know, in a case of benzene it is sp2 hybridization, but when we come across benzene, the hybridization is the sp, highly reactive one, where the carbon involved, instead of 2 bonds it gets one more extra pi bond, but the pi bond formed here is little weaker, as the sideways overlapping of the p orbital takes place, it is weaker. So, this is all about the reactive intermediate that we have, reactive intermediates. So, thank you so much.